Good day, everyone. I am Justiny the One, a teacher learner and a mathematics educator. Today, I would like to share my thoughts on a question: what does effective mathematics teaching looks like in Kalinga? When I imagine a mathematics classroom in Kalinga, I see a classroom where students are not afraid of numbers, formulas, or solving problems. I see learners actively participating, asking questions, sharing ideas, and connecting mathematics to their daily lives. For me, effective mathematics teaching is not simply about getting the correct answer, it is about helping students understand concepts, think critically, and appreciate how mathematics helps them make sense of the world around them. Today, I will discuss three important principles of effective mathematics teaching and how this can be applied in a Kalinga classroom. First principle: focus on sense-making and conceptual understanding. The first principle is helping students understand the meaning behind mathematical concepts rather than memorizing of formulas. Many students can memorize a formula today but forget it tomorrow. However, when students understand why formula works, they can remember it longer and apply it in different situations. One specific Kalinga example is that, imagine I am teaching area of a rectangle to a grade 7 students. Instead of writing the formula, area is equal to length times width immediately on the board, I would first present a situation familiar to them. Maybe I might ask, suppose your family owns a rice field that is 20 meters long and 10 meters wide. How can we determine how much land is available for planting rice? Students may suggest measuring the field or counting spaces. Then, I would guide them to discover that multiplying the length and width gives them the total area. In this way, students understand where the formula comes from instead of simply memorizing it. As teachers, our goal is not to make students memorize mathematics, but to help them understand it. Second principle: encouraging problem solving and reasoning. The second principle is allowing students to think, analyze, and explain their solutions. Mathematics is not just about finding answers, it is about understanding the process used to arrive at those answers. One specific Kalinga example is that, suppose I give this problem. A farmer harvested 150 kilograms of rice and wants to divide it equally among 5 family members. How many kilograms will each person receive? Some students may use long division, others may use repeated subtraction. Some may use multiplication facts. After solving, I would ask, how did you get your answer? Can anyone solve effectively? Instead of focusing only on the correct answer, students learn to explain their thinking. This helps them become more confident and independent learners. They will realize that there can be different ways to solve the same problem. The third principle: connecting mathematics to learners' culture and real life. The third principle is making mathematics meaningful by connecting it to students' culture and everyday experiences. Students learn better when they can relate lessons to things they see and experience every day. One specific Kalinga example is that when teaching symmetry in geometry, I can use traditional Kalinga weaving patterns. I can show a picture of a woven cloth and ask students, can you find a line that divides the design in 2 identical halves? Students will observe the patterns and identify lines of symmetry. Instead of learning symmetry from abstract figures alone, they learn it through something that is part of their culture. This helps students appreciate both mathematics and their cultural heritage. Another example is using local market prices to teach percentages, discounts, and budgeting. When students see mathematics in real-life situations, learning becomes more meaningful and engaging. Among the three principles, the one I find the most difficult to apply is encouraging problem solving and reasoning. This is because many students are used to receiving answers directly from the teacher. Some students become hesitant to explain their ideas because they are afraid of making mistakes or being judged by others. As teacher, I know that creating a classroom where students feel comfortable sharing their thoughts will require patience, encouragement, and consistent practice. On the other hand, the principle that I want to prioritize in my teaching practice is that connecting mathematics learners, culture, and real life. I believe students learn best when they see the relevance of what they are studying. When lessons are connected to rice farming, local markets, weaving, and community experiences, mathematics becomes more interesting, understandable, and memorable. And of course, to conclude, effective mathematics teaching in Kalinga is not about making students memorize formulas and complete worksheets. It's about helping learners understand concepts, solve problems, explain their thinking, and connect mathematics to their everyday lives and culture. As teachers, we should remember that every learner can succeed in mathematics when given the opportunity to explore, ask questions, make mistakes, and learn from those experiences. Because mathematics is not about numbers. It's also about helping students think, reason, and become confident and problem solvers for life. Okay, bye-bye!